So now we're going to go and move on to look at wormholes, okay? So we've just finished talking about string theory, okay? So I just said that could promote time travel in the same way that Gödel's theory of the rotating mass universe did, okay? Because it's distorted and curved, okay? Now, space-time in the universe is, it says, curved, okay? It is warped, but it's warped by the energy and mass that inside it, okay? But therefore, because space-time goes one way. In order to time travel, okay, we need to reverse that. We need to go back in time. We need to reverse that theory, okay? Which obviously is past, present, future, wherever we want to go, okay? So therefore, we need the opposite of the energy, opposite the mass, opposite the density, opposite of everything, okay? But to do that, we need to have negative energy, negative mass, and negative density. Now, you go, well, according to the classical laws that we currently know, that is just not allowed. You can't have energy, you can't, because we know the conservation of energy, which is the classical energy law, says energy cannot be created or destroyed or removed entirely. And by having negative energy, we're removing it entirely. We're assuming this energy was existing before and is not being transferred to any other form, just been removed from the universe, okay? But obviously, because I've drawn it on the board and because it's in various papers, now we can theoretically time travel into the past and present, future, okay? And we can do that by the laws of quantum mechanics. Now, quantum mechanics, one of the theories that we're going to base this off is Heisenberg's uncertainty principle. His principle said we don't know the position and the velocity of a particle, because obviously if you try to look at it through an electron microscope, it appears too fuzzy, and we can almost specify its velocity and its position, but we can't have both, okay? And that allows us to say, well, it could be negative energy, it could be positive energy, as long as it's balanced out by something else somewhere else. In other words, if you've got negative energy to allow us to create this wormhole, as long as we've got positive energy somewhere else, theoretically, okay, the energy balances out and we haven't actually lost energy. So it does almost agree with the classical law, but obviously in the obvious ways it doesn't, because we're removing energy. Anyway, so this is essentially what it creates. So we use that negative energy to bend space and time, or space-time, in the opposite way that mass and energy do. Okay, because obviously negative energy, negative mass. And it creates this wormhole where we can, it's almost labelled as hyperspace, okay? So it's very science fiction-y, where we go from the present to the future, okay, by the use of quantum mechanics and Heisenberg's uncertainty principle, okay? So that's really all you need to know. As I said, that's just a quick sketch that I had to go drawing for you. Because we don't know, because there can't be a point of zero in the magnetic field or electromagnetic field lines, otherwise we would obviously know the position and the velocity, which obviously contradicts Heisenberg's uncertainty principle. We need another theory to back that up, to say yes, we can have these wormholes, okay? And to be able to do that, we need these vacuum fluctuations, which, as I said, it's quite obvious in a vacuum is where there is no air, so a bit of pressure, okay? And in these vacuum fluctuations, essentially what happens is we have periods where we have, hopefully from the AS knowledge, we should know about particles and antiparticles. So you have the electron and the anti-electron, which is, just a recap, is the same particle but just totally different charge. So obviously electron is negative charge, so the positron must have a positive charge, okay? So just a recap for those who don't know about particles and antiparticles. Anyway, so these vacuum fluctuations, when the particles and antiparticles collide with enough energy, okay, they explode into photons, okay? And essentially what this vacuum fluctuation is saying is there are these particles and antiparticles, and they collide and they obviously produce photons, and then they annihilate each other, and then the photons with enough energy turn back into particles and antiparticles, okay, and then they exhibit the same thing, and the cycle goes on and on. Okay, and obviously these particles and antiparticles allow us to have negative, the substantiated theory of negative energy. Okay, so obviously these particles are said to be virtual particles. We can't detect them with a detector. Now you're going, how the hell does these particles and antiparticles, how do we say they are vertical particles if we can't detect them with a detector? Well, we use something called the Clasmir effect. And the Clasmir effect is just about, it's essentially, I'll just draw a bit of a guide here. So we've got these two metal plates here, okay, and essentially we've got these particles and antiparticles. So I'll put one positive, one negative. Obviously, you know, depending on what particle it is, the positive might be the antiparticle, and negative might be the particle, or vice versa. Okay, so what we've got here is obviously put it in some kind of box with two metal plates. And now, because these are interacting with each other and exploding and turning into photons, okay, when we try and put light through it, okay, or some kind of wavelength, alright, it acts as an organ tube. Essentially, because these photons that are produced interact with the photons that are coming through, and these photons that are coming through turn into the particles and antiparticles, okay, only certain photons or certain certain wavelength or characteristic frequencies are therefore emitted through this, okay, because of the interactions, okay. So that's one little bit of this effect. And obviously, because there's a vacuum fluctuation, there's actual pressure on the inside, because obviously, you know, if it's vacuum, it's a vacuum, then there's obviously pressure pushing out as well. But if it's not a vacuum, then it's equal. But if it is a vacuum, then there's a lot greater force pushing it together. Okay, it's keeping the air out because the air wants to get in, obviously. Okay, so what happens is when these particles and antiparticles turn into photons, okay, they emit through. So the force is a lot less inside here. So it slowly, very slowly shrinks. But the fact that there is actually a force pushing it out, because all we're doing is putting like light through here, and there's a force pushing it out, proves the existence of these particles and antiparticles, which we know as the Clasmir effect. Okay, and this proves that obviously these particles and antiparticles exist, which means we can have the negative energy, which means therefore we can show these principles of the wormholes, which will allow us to time travel into the past and future. Okay, so sorry it's not been the smoothest of videos. I rather was hoping it would be a bit smoother than that, but what can you do? It's interesting, it's going to get, I'm afraid. I might have another go at this later on, but as I said, I've done this video enough times now. Get slightly bored of doing it. Exciting. But anyway, if you got any questions, as I said, I tried to, when I was talking through it, I mentioned that I made a little mistake towards the start of it when I was talking about, I was trying to explain the Heisenberg's uncertainty principle, and from there I made a little bit of a mistake, but I did sort of talk around my errors. As I said, I mentioned my errors, so if you watch the full video, you should be totally okay. But just to recap, if you just skip to the end, okay, Heisenberg's, we are allowed to create wormholes which have negative energy and negative mass, which don't agree with our classical laws of the conservation of energy, obviously, because we're moving energy that existed and we're saying it now doesn't exist anymore. We could do that through the laws of quantum mechanics that say through Heisenberg's uncertainty principle, which say we can have negative energy as long as it's balanced out by positive energy somewhere else. Okay, and obviously that comes from these particles and antiparticles having negative energy, and we know through that they exist because they're vertical, even though they're vertical particles, as we can't detect them through a particle detector, okay, because of this Clasmir effect, which just says there's a bit of pressure, there's a lot of pressure pushing in, but there's also a small pressure force pushing it out, okay, which just demonstrates the fact that these particles are actually existing, okay. So, as I said, hopefully that makes a little bit of sense. Yeah. So I do apologise. I'm really kind of not very happy with that, but I've got everything in there. It's all correct in the end. So, as I said, I do apologise yet again about the shoddiness of this video, but what are you going to do? I might put a little comment on saying sorry. But anyway, thanks for watching, and we'll see you in the next video.